Hello everyone, welcome back to the channel. One of the most common Kubernetes interview questions is the difference between deployment and stateful set. So many of us know what is the definition. However, interviewers don't want to know the definitions. They want to know when we generally use that and what could actually lead to the issue in the production if it is not used properly. So in this video, we will understand the concept, architecture and the real world uses. So let's get started. Now, why this question matters? For the interviewers, this question is to test whether you understand the stateless or and the stateful workloads in Kubernetes. So let's understand it. Now, Kubernetes offers multiple workload controllers. Now, there are two most of the commonly used controllers. One is deployment and second is stateful set. Now, if we use a wrong controller, then it will cause an application failure, sometimes data loss, or even database replication issues. For example, if you are deploying MySQL using a deployment, now MySQL is a is a database. So since MySQL is a database, it is stateful set. It is not a stateless set. The database is generally a stateful set. So instead of using a stateful set, we are using deployment, which is wrong. So if you are deploying MySQL using deployment, which is incorrect, instead of using stateful set, then the database may lose its stable identities. Even the persistent storage mappings during scaling or pod recreation can be gone. That is why understanding the difference is important for both the interviewers and the production environment. So we'll understand first what is a deployment. A deployment is used to manage stateless application. Now, what does that mean? Stateless means application does not depend on local pod data. That means deployment means stateless. And what does stateless mean? That the application is not dependent on the local pod data. That means if the pod is getting disappeared, is getting deleted, or anything goes wrong with the pod, the Kubernetes will automatically create another pod and the application will continue to work normally. And there are the examples of deployments which is equal to stateless, means they don't need to be dependent on the local pod data, and the examples are front end applications or the REST APIs, the web servers, the microservices. So these are few examples of the stateless applications that don't depend on local pod data, in short deployments. The key idea to understand in deployments is that every pod is identical and interchangeable. It is not unique, it is identical, so it can be changed. So if one pod crashes, then Kubernetes will create a new pod automatically without affecting the application. Let's go little deep dive here. Deployment will use replica sets internally, and the replica set will ensure that the desired number of pod replicas are always running. So if you configure 3 replicas and one pod is dying, then Kubernetes will immediately create a replacement pod. We'll see an example of a deployment over here. Suppose we have an e-commerce website. Now this e-commerce website, we will deploy 3 replicas. One is pod 1, pod 2 and pod 3. These are the 3 replicas. Now we will have a load balancer for this website, and that load balancer will distribute the traffic across all the 3 pods. Now suddenly pod 2 is getting crashed. Due to some reason pod 2 crashes. So Kubernetes will go ahead and create another pod, maybe a new pod. It might get a name like pod2.a. It doesn't matter because the application is stateless. So users also would not notice any difference. So the main important point to understand is for stateless applications, pod identity is not important. So this was about deployment. Now we'll understand what is stateful set because we need to know the difference between them. So now we'll come to stateful set. So it is the opposite of stateless. Stateful set is designed for application that would require persistent identity and storage. There, they did not need unit identity. Here, they need an unique identity. They are generally for applications. Here, they are generally for the storages. So unlike deployments, every pod in a stateful set will have a unique and a stable identity. Few examples are databases like MySQL, PostgreSQL, MongoDBs, Kafka. Now each pod will have a stable identity and a persistent storage. Now these applications store data and they are often participating in the clusters or application groups, and they must maintain a consistent host name and a storage volume. Let's go little deep dive and understand the stateful set. So when stateful set will create a pod, it will name them sequentially like MySQL 0, MySQL 1, MySQL 2. Now if get a pod gets deleted, MySQL 1 is getting deleted. So it will keep the same name and the storage volume. We'll explain little more deeper with an example. We have a stateful set of MySQL. So we'll imagine a MySQL cluster here, and then it has a pod MySQL 0 which is acting as the primary database, and MySQL 1 and MySQL 2 will act as the replicas here. Now the replication process will depend on the stable host names. If the pod names will keep on changing, the replication will break. Stateful set guarantees stable network identity which solves this problem. So we'll go a little more deep dive. Now each stateful set pod gets its own persistent volume claim. So if a pod restarts, the storage remains attached. This prevents the data loss because it has its own persistent volume change. So even if the are getting restarted, the storage will remain attached. So there would not be any data loss. Now what is the key differences between both of them? Deployment is stateless, stateful set is stateful. Deployment has dynamic pod names, stateful set has a stable pod name. Deployment has a shared behavior, however, stateful set will have unique identities of the pod. Deployments are very easy when it comes to scaling. In stateful set, we have sequential or ordered scaling. Deployment, they are using temporary storage, and stateful set, we have persistent storage. Let's go a little more deep dive. So, a deployment focuses on the availability of the application. A stateful set focuses on preserving application identity and its data. So let's go and see a real production scenario. Now a company is running a PostgreSQL on Kubernetes. Initially they will use a deployment. Now this is not advice, but suppose initially they are using a deployment. Now everything is working fine. Everything is proper. Suddenly we have a pod crash. Now Kubernetes will create a new pod because there is a pod crash. It will have a different identity. Now the replication will break here because the replica nodes can no longer identify the original primary nodes. When the company migrates to stateful set, okay, because it is not achieving the objective. So now the company has to migrate to stateful set and get it corrected. Now Postgres 0, Postgres 1, Postgres 2, like that we have made the identities. Now the replication is stable. So this is the problem, and then we went to the solution. And this is one of the strongest practical reasons for using stateful sets. Now suppose in an interviewer, if they ask, give us an example or tell us when you would use deployment versus a stateful set. So in this scenario or in this question, a strong answer would be I use deployments for stateless applications where pods are interchangeable and don't require persistent identity, and I use stateful set for stateful applications such as databases, which require stable network identity, like the unique identities, they need persistent storage and ordered deployment or scaling. Now, this answer sounds much more senior than just simply saying deployment is stateless and stateful set is stateful. Okay, this was about this video. Before we go ahead and conclude it, I would like to once summarize this. Use deployment for APIs, front-end application microservices, and use stateful set for databases, Kafka, distributed systems. The key difference is stateful sets will preserve the identity and storage, while deployment will focus that on scalable stateless workloads. So now in the next video, we'll discuss daemon sets and why Kubernetes run on pods on every node. And I hope you found this video useful. Please